Hi devs, I'm Giovanni Laquidara, developer evangelist at Amazon, and today we're going to learn more about Amazon Device Messaging and how to send push notifications to your users. Amazon Device Messaging, ADM, lets you send messages to Amazon devices that run your app, so you can keep users involved and up to date. You can use ADM to give your users a game update or let them know that a message from their buddy has arrived. And now ADM supports push notifications. Skip to the push notification part of this video if you already know about ADM and want to use this feature. The architecture of ADM follows three key principles. Protected. As a sender, your servers are verified via the auth 2.0 client credential flow. As your message passes to a device, the endpoint connections are authenticated and protected with industry standard SSL encryption, and ADM uses the standard Android permission system to direct the message to your app only. Flexible. ADM doesn't process the data you send in any way. Your message is solely required to be no greater than 60 bytes in size and to send the data in the form of a JSON object. Simple. ADM is a transport mechanism, delivering message data to your app. It does not provide any built-in user interface or other handling for the data. There are four components involved in sending a message with ADM, two of which you control. Your servers, identifying themselves to ADM servers with an access token and sending message containing JSON data to the ADM servers for delivery to your app. The ADM servers, validating your server's identity and sending the message to the ADM client on the device. The ADM client, handling your app registration process with ADM servers and receiving messages from them and passing them to your app. And last but not least, your app, registering with the ADM clients to receive and handle the messages. So how do we set up ADM? First of all, we have to head to the SDK download page and download the Amazon Device Messaging SDK for Android. The downloads includes the ADM jar file, the API documentation and some samples. Then we can extract the zip file in a directory we prefer. To use ADM, we need to add it to the libs folder of our Android project. If we are using Android Studio, we can just copy the Amazon Device Messaging jar file from where we extracted the ADM zip file and paste it into the libs folder. Then right-click the jar file and at the end add as a library. This automatically adds the implementation commands to the build Gradle file. Finally, because we need the library only at compile time rather than runtime, we have to change the following declaration from implementation to compile only. After these steps, we are almost ready to integrate ADM into our app. Let's see how. To use Amazon Device Messaging ADM, we must be able to uniquely identify our app to Amazon. Amazon provides you with credentials for this purpose. ADM uses an API key to verify your app's identity. We can obtain this key from the Amazon Developer Console. For more information on how to do this, you can check out the link on the screen, which you can also find in the description below. After dealing with the credential, we can open the Android manifest XML and add the Amazon namespace. Then we have to declare the permissions needed to support ADM. The next step is explicitly enable ADM, adding the Amazon Enable feature element, and declare whether our app requires ADM with Android required set at true, or can work without ADM being present with Android required set at false. If we specify Android required as at false, our app must degrade gracefully if ADM is unavailable. After that, we have to declare a broadcast receiver to handle the registration and receive the instance that ADM sends. ADM requires that we define the receiver in the Android manifest XML file rather than programmatically, and immediately after Amazon Enable feature. To enable our app to receive messages, our app must contain a valid API key. We can obtain the API key from the developer console. For a pre-release or debug version of our app, we must create an API key and store it in the asset folder of our project. Insert your API key as the only data in this API key text file. For a release or production version of our app, if our app uses the App Store SDK, we must create an additional API key for the release version of our app. For a summary, see this table. After dealing with the manifest and the API key, we can go straight away to the code. we have to create an instance of an ADM context and initiate the registration with ADM for this instance of our app. We should run this code each time our app starts, for example by pressing it within the onCreate method. If our app is already registered, getRegistration_ID returns the registration ID for this instance of the app, and startRegister isn't called. If it's the first startup of the app on a given device, or if a previous registration failed, this code begins the registration process. To handle the registration and the messages, ADM has three classes that we must extend. ADM Message Handler Job Base for handling messages on the latest Fire devices, ADM Messages Handler Base for handling messages on older Fire devices, and ADM Message Receiver for forwarding messages to the appropriate message handling class. To choose which message handler to use, we need first to check if the new ADM services is supported. Then, when we create the receiver, we can select the new job-based handler if the latest ADM is available. The message handler has 4 callbacks that we can extend. Unregistered, call when the registration ID is ready. Here we will receive the registration ID that we can pass to our server so that it can send message to our app instance. On unregistered, call when our app is unregistered on this device that we can use to inform our server that this app instance is no longer a valid target for messages. On registration error, used to handle error in the registration process. We could decide here that our app may degrade gracefully, or we may wish to notify the user that this part of the app functionality is not available. On message, call when a message is received, where we can extract the data. We are now ready to the ADM integration, sending our first push notification. ADM has a web console that you can use for this scope. Go to the ADM console from the developer console. This console is under Apps and Services tab and Device Messaging option. In the Test Your Message screen, select the target app. Enter the client ID and secret and device registration ID. Choose the duration of the message in the Message Expires After section. Choose the message type. Select Send Test Message to complete your notification. Check for the message on your device. The other way we can test is by using a server-side script. You can check the code of a sample script at that URL, or you can use the sample containing the downloaded zip file of the ADM SDK. ADM now supports 3 types of messages. Data message, handled by your app and defined by custom key value pairs. You can use a data message when you want to use custom logic to process a message, for example to send messages to your app background tasks. Notification message, handled by the ADM SDK and defined by preset key value pairs. Use notification messages for a message that is automatically displayed to the user, such as a promotional offer or a marketing notification. Data and notification, a notification message that also contains a data message payload or custom key value pairs. And that's a wrap. Thank you for your time. I hope this video was useful in understanding how to implement the ADM SDK and use push notifications. For more information, you can check out the link on the screen. You can also find all these links in the description below. To discover more, head over to developer.amazon.com or join us on Twitch, Amazon App Dev, every Tuesday at 6 PM GMT. And finally, if you enjoyed this video, don't forget to like and subscribe.